All right, guys, welcome back to Burt's Basics. Now, I know this might seem weird because we're starting in the middle, but this is actually part 2. So if you haven't watched part 1, go back to part 1. We're doing blood flow through the heart. So here's everything we missed on the last video in case you got to catch up. Remember, colors are important, okay? So when we talk about blue, okay, blue means deoxygenated. Blue. Blue means deoxygenated. I'm not starting over. I don't care. So we start with this guy, my superior vena cava. Remember, I'm going fast. Watch the last video. Inferior vena cava, they're both veins, gigantic veins bringing sucky deoxygenated blood into the right atrium. Okay? The blood pools in the right atrium. Gravity will go through most of the way, but then I have a nerve, a bundle of nerves right here in the right atrium called my SA node. He's going to make it kick, and the blood's going to go through this valve into the right ventricle. But the problem is you need to know the names of all of these guys. So we need to know the name of the door, which is called my tricuspid. We need to know the names of the strings that help prevent the backflow of blood, chordae tendineae, and we need to know the muscles that anchor them, papillary, papillary, papillary. So that's where we're going to start right now. Now, we have not done anything with blood yet. The blood still sucks, okay? It's still blue. So let's go ahead and clear our diagram really quick, and let's go back to blue. Okay, so right now the blood is chilling in my right ventricle. And I got to move it. It's got to go. So now the question is, what do I do now? Everyone's like, well, it can't go backwards. You know it can't go backwards. The tricuspid is like Fort Knox, man. This thing is locked down. So it cannot go back to my right atrium. Okay, your heart is a one-way street. It can only go one way. So now let's talk about this guy. Let's talk about red. Look how much muscle there is here. Oh my goodness, that's a lot of muscle. That muscle can squeeze this right ventricle and make that blood shoot. And it's going to make it shoot. It's going to make it shoot up this way because it can't go backwards because the tricuspid, let me write tricuspid. Actually, I don't have to write tricuspid. It's right there. Tricuspid's in the way. So now the question is, how do I get that muscle to contract? And you know how I do that with the color green. Remember, green are all about nerves. But the problem is you have a bundle of nerves right here called your SA node. How in the world is that bundle of nerves going to get down to these muscles down here? Well, obviously, we got to have some parts and pieces of this. So don't panic about this next picture, okay? It's not as bad as you think. This is our nerve collection. Now, I know this sounds scary, but just kind of look at the picture first, then we'll do the word second, okay? Right here, this is my SA node. The SA node's the master, okay? He's the pacemaker. He's the number one. Every test question in math, I promise you the answer is SA node. But he is SA, which means he makes the atrium contract. I need a V in here somewhere, and that's where this guy comes in. There's a secondary node who's also in the right atrium, right there, number 2. And his name is called the AV node. The AV node stands for atrial ventricular node. He is going to make my ventricles contract. That's what his job is. He's going to make the ventricles contract. But to do that, look at this long nerve. Okay, can I just draw it first and we'll name it, okay? Then he sends one nerve all the way down to the middle of the heart. Now, this is a word we haven't used too much right here. We use it in skeletal system. This is called the septum. Okay, a septum is nothing more than a wall or divider. So this is my cardiac septum. Okay, see your word septum right there? So I don't care about that. I have to send a nerve to my septum, okay? Let me erase this. I don't like this. Let me just do a quick erase really quick. Okay, now I'm going to go back to my pen. So what's going to happen is he's going to send a single nerve to my septum. Then look what happens in my septum. In my septum, it branches. See how it branches? Why do you think it branches into 2? Oh, I think I know why. Because you have 2 ventricles, okay? One thing we haven't talked about yet, which we'll get at the end, is the atriums and the ventricles contract at the same time. So that, the atriums contract together and the ventricles contract together. If you were in class and I said, hey, what sound does a heart make? Everyone would do the same thing. If I'm like, what sound does a heart make? Everyone would be like, pow, pow, okay? I don't care what they do. Boom, boom, okay? Scientifically, I'm supposed to teach you lub-dub, by the way. But everyone does 2 sounds. And what I want you to think of is I want you to think of atrials, ventricles. Atrials, ventricles. So I branch because I actually want to get both ventricles going at the same time. Then what happens is after we branch, sorry, let me go back to green because I'm trying to keep mine color-coded. The branches are going to curl around, this one will curl around this ventricle, right? And then this one will curl around this ventricle. But then coming off here, I have all these little baby nerves that need to hit all the heart muscles. And every one of these branches has a name. So let's go ahead and do them. Remember, don't panic. This is my SA node. The SA node is the natural pacemaker of the heart. He then fires to a secondary node. The secondary node is called the AV node. The AV node needs to get down all the way down to these muscles, okay? So to do that, I have this bundle, one nerve that comes out. Notice there's only one of them. That's how you're going to help on this test. That one is called the bundle of His, okay? His is actually someone's last name, so I imagine we're going to change that sometime, okay? Is Wilhelm His who discovered this. So this is called the bundle of His, and this is the bundle of His until it branches. And how cool is this? That what should we call it when it branches? How about we call it bundle branches? So this is the bundle of His. These are the bundle branches. Remember, they are dividing in the septum, which is nothing more than a wall, right? And then they're going to curl around, and these little fibers coming off are called Purkinje fibers. Purkinje fibers. So let me go ahead and draw this one more time. You can pause this if you need to write them down. But this is how I would master the nerves, okay? So let's go ahead and get my heart set up. Whoop, whoop. This is my right atrium, left atrium, right ventricle, left ventricle. Okay, and by the way, I do this again and again and again and again. I have my first bundle of nerves. You know who that is. That's my almighty SA node. I have my second bundle of nerves. Notice they're both in the right atrium. We call this guy the AV node. As soon as the medulla says, let's go, okay, the SA is going to make the atriums contract, and then he sends a signal, doot, 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 to the ventricles. So the ventricles will fire right after, but the ventricles got to get all the way down to the bottom. Okay, so let's draw my muscle really quick. My goodness. Okay, this is all muscle down here. Somehow the AV node's got to get down there. Well, he does. He has one nerve that comes out of him. We call that the bundle of His. Then in the wall, it branches. We call these bundle branches. One branch will go to these muscles. One branch, will go to those muscles. But then coming off here, I have lots of little nerves that are going to go stimulate this muscle because it's a big muscle to try to stimulate. And we call those little branches Purkinje fibers, okay? That right there is what we call the conduction pathway of the heart. Conduction pathway of the heart, aka the nervous part of the heart. That is one of your bullet points. And it's as simple as this, okay? SA fires first, AV second, bundle of His, branches, Purkinje, okay? That is your conduction pathway of the heart, okay? Good job. Okay, so now let's go back to our diagram. Okay, I know this is kind of tedious. I take forever on the right side, and I'm really fast on the left side. So here's my superior vena cava. Here's my right atrium. Blood is pooling, okay? Here's my inferior vena cava. Blood is sucky, deoxygenated, blue, okay? I got to get the blood out. You know how I'm going to do that, okay? I'm going to hit it with my SA node. Then it's going to go through a valve. The valve is my tricuspid valve. Then it's anchored by strings, chordae, tendonae, papillary muscles. The blood did not get oxygenated, by the way. It just moved. So it's still blue in the right ventricle, and it's still sucky. Okay, we didn't change anything. So now I got to go back to green and hit it again. So now I get my AV, bundle of His. In this wall, it branches. I don't care about this branch right now because we're going to focus on the right side of the heart. This branch is going to come around to all this muscle, and then I'm going to have little guys telling all those muscles to contract, and those are Purkinje fibers. The Purkinje fibers are going to hit. Now let's follow the pathway of blood from there. This blood right here, all this blue blood, where's it going to go? The muscles are going to squeeze. It's going to shoot out of there like a rocket. It cannot go backwards because remember, the tricuspid valve has blocked that path. So we got to find a new path for it to travel. And we have one. Do you see that pathway for it to travel? It's right here. It's going to cruise up here. So let's draw it. Oh, I need blue. I need blue. I need blue. I need blue. And guess what? It's going to hit another door. I told you there are 4 valves in the heart you have to master. This one is called, don't freak out about this name, okay? This guy is called a semilunar valve, okay? We actually have two of them. This is also a semilunar valve, okay? So we have two semilunar. So let's look at the word semi, okay? Semi in med term means half. Luna means moon. So if you want to look at these, think of these as half moon-shaped doors. So can I go ahead and erase some of this because it's kind of crazy? So now let's look at this really quick. So if you look into the blood's pooling here in my right ventricle. This is locked down, so it can't go backwards. The blood's coming up, and it's going to go through these semilunars. So now the question is, semilunars are named after what they do. So this guy's name is called the Pulmonary Semilunar. That's his name, Pulmonary Semilunar. So think of a half-shaped moon like this and another half-shaped moon. There's a couple of them. So the blood's going to shoot through these half-shaped moons, semilunar. And then what happens when the blood starts to try to come backwards when the heart relaxes? Well, it gets caught because you know what the purpose of valves are. Valves are to make sure the blood doesn't go backwards. So now the question is, what is pulmonary? Pulmo is lungs. So why do you think they call this the lung valve or the pulmonary valve? Well, you guys know why. This is all blue. And you know what blue means? Blue means this is sucky blood. It's deoxygenated. We got to oxygenate it. So now we're leaving on the pulmonary semilunar valve. Okay? So now let's keep on going. The blood just shot out of the pulmonary semilunar. It cannot go backwards. Now this is a tricky part, but I think you guys are brilliant enough. You guys should be able to master this. Okay? This is, without doubt, this is an artery. You know why this is an artery. The blood is leaving the heart. It's going away from the heart, okay? But, we call this the pulmonary, remember pulmonary is lung, trunk. That's a scientific name right there, and that's what I'm going to hold you to. You've got to call it the pulmonary trunk. You've got to call it the pulmonary trunk. That is the trunk. Think of a tree. This is the trunk of the tree, and then eventually the trunk will what? He will branch, okay? The branches of the trunk, these guys are all leaving, okay? They're all going towards the heart, or sorry, towards the lungs. We got some on this side too, okay? Leaving. These guys are called pulmonary arteries, okay? So on the test, you guys got to make sure you get them apart, because if you call this guy a pulmonary artery, you're correct, but I'm going to mark you wrong. He is an artery, but we call him the pulmonary trunk. These are my pulmonary arteries, and notice something very unique about these arteries. They are blue. The reason why they're blue is because they have sucky blood, okay? But guess what they're about to do? They're about to go to the lungs to get oxygenated. That's where oxygenation takes place. Okay, now we have a whole unit to talk about lungs, so I'm not going to talk about lungs too much. All I need you to know is the following. Look at this diagram and see if this makes sense. Okay, who am I? Please say this out loud. Who am I? What's the name of this valve right here before I leave? This is my pulmonary semilunar. This is my tricuspid right there. Okay, so then I got my pulmonary trunk. And then I got my pulmonary arteries, right, going towards the lungs, and they're blue. But then notice what's happening right here, and here, and here. What's going on? It's going from blue to red. How in the world is it going from blue to red? Well, guess what the lungs do? The lungs do what? They oxygenate the blood. So now I got red, sexy, amazing, wonderful, beautiful blood. But now it's got to go back to the heart, to the heart, to the heart, towards the heart, towards the heart. Yo, 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 okay? So if these guys are pulmonary arteries going away, what do you think these guys are in red, which is very unique? These guys are pulmonary veins in the red because they're going back to the heart, so they are veins, but they are sexy oxygenated blood. Every class tries to teach you that veins have sucky blood. Most of them do, except the pulmonary veins, which are amazing. All right, guys, you've mastered the right side of the heart. It's time to master the left side of the heart. This was part 2. Let's go to part 3.